Hey, welcome to another video explaining balancing chemical equations. This time we're doing practice sheet number 3 and problem number 3. We're on to word problems. So we have sodium phosphate and calcium chloride react to form calcium phosphate and sodium chloride. Now again, these are all type 1, but we have polyatomic and we have binary type 1 compounds. So what we need to do is we need to figure out what are the charges for each one of these elements, or I should say binary elements, monoatomic ions, or the polyatomic ions. So let's go ahead and give sodium. If you don't know what sodium is, what the charge is, we're going to look on page 13 of your packet. So again, we'll scroll down to page 13 in your packet. And we'll notice that right away, sodium is right over here. Na is a +1. Okay, so we can get back out of that. So we know that sodium is a +1. We go to phosphate. Where are we going to find phosphate? Well, we know because it ends in ATE that it is a polyatomic ion. Okay, so we're going to again go back to our packet, scroll all the way down to the very last page, and we look up phosphate. I don't see it here. Okay, there's phosphate, PO4, and it's a -3. So we're going to get back out of this, and right above this, we're going to put a -3. Then we can go over to calcium, okay, because we're going to do this also. In calcium, again, if you don't know what it is, we're going to go back to our monoatomic ion sheet, because it's not a type 2 because there's no Roman numeral. So we're going to go ahead and go to this monoatomic sheet right here and see calcium is a +2. So let's go ahead and put a +2 above calcium. And then chloride. We know that it is not excuse me, polyatomic because excuse me, it ends in IDE, and it's chlorine that's changed to chloride. So if you don't know what it is, again, you need to go back to your packet, find chlorine. Here's the symbol for chlorine, Cl. It is a -1. So we'll go above this, we'll put a -1. Now, I don't need anything else for the other side because I already have the ions on the product side. So sodium is a +1. Phosphate is a -3. So they don't cancel each other out, so we're going to crisscross them. And so I'm going to move the 3 down here, and I'm going to move the 1 right there. Now again, I'm going to go ahead and I'm going to make this smaller by a little bit, just so I can go ahead and put these things in. So the 2 here is going to be, or the calcium is a +2. The chlorine is a -1, so we're going to, again, crisscross because they don't cancel each other out. So I'm going to put a 1 here, and I'm going to put a 2 right there. Now this is going to help me out when I go ahead and write my problem out. So I'm going to go ahead and write my problem out, where you have to do the symbol for sodium. If you don't know what it is Na, but again, you could always go back to your packet, scroll to your periodic table, find sodium, which is right here, sodium, and it is Na. Okay, and we're going to put a 3, a subscript of a 3 there. Then we're going to go ahead and put our phosphate. And if you remember what our phosphate was from our other page that we went to, it was PO with a subscript of 4. And I only need one of those, so we're not going to put that. If I needed more than one polyatomic ion, remember we'd have to put the polyatomic ion in parentheses. This 4 does not mean I have 4 of the phosphates. I have 1 phosphorus and 4 oxygens. Okay, so we're going to move that over, and then we're going to add to that calcium chloride. So we're going to put in our symbol for calcium, which is Ca. We have to put a 1 in, so we're not going to put that down. And then we'll put chloride, which is Cl. And we do have a subscript for this one, which is going to be 2. And then we're just going to go ahead, and we know that that's going to react. Those 2 compounds are going to react, and they're going to form calcium phosphate. So now again, I can go ahead and put the charge over here for calcium. We said that that charge was a +2, and our phosphate was a minus 3. And then we go to sodium. We're just using the ones from over here because they're always the same charge as what they are on the other side. So that's going to be a plus 1. And then our chlorine, oops, is going to be a minus 1. So we're going to go ahead and do calcium phosphate. Since the charges do not cancel each other out, we're going to crisscross those numbers. So I'm going to put a 3 right here, and I'm going to put a 2 right there. So we crisscrossed those numbers. These do cancel out. So because they cancel out, I only need 1 of each one. So we're going to go ahead and start with our calcium. The symbol for calcium is Ca. I need 3 of them, so we're going to put a 3. And then we're going to put our phosphate, which is PO4. But I need 2 of them. So we have to put parentheses around the phosphate. So we're going to put a parentheses there. We'll go back to right at the beginning here and put parentheses there. And again, we're going to put down a subscript of 2 because I need 2 of those. And another byproduct is going to be sodium chloride, but I only need 1 of each one. So we're sodium is Na and chlorine is Cl. So there we go. There we have our balanced chemical equation, or unbalanced chemical equation, or what I like to call our skeleton equation. It's just the bones of everything. We have to double check, and we can't balance it correctly if we don't have the correct compounds here. So figuring out those correct compounds are really important. So knowing your nomenclature is important. So we're going to go ahead and look at these right here, and there are no elements that are by themselves, so we don't have to worry about diatomic elements. So we're going to go ahead and start off by, again, we're going to put our molar mass, or molar ratio, excuse me, because that's what we're calculating. And so once we get done with that, we're going to put our coefficients over here in that. So let's go over to the other side. We're going to go to the middle, and we're going to put down all the elements that we have. I'm going to put down Na. And there's a polyatomic ion. If I have it on both sides, I want to save that to the end. So I like putting calcium in. And then I put our chloride in. And then I like to put in our polyatomic ion. And I do that to keep that polyatomic ion together. It is together on each side. So now we're going to go ahead and put down how many we have of each one. Well, how many sodiums do we have? I look right here and it says we have 3 sodiums. So I'm going to put a 3 there. Oops, not right there. I'm going to put a 3 right there. Then I can come over the other side and look at it, and I only see 1. So I'm going to put a 1 right there. Go to the calcium. Calcium's right here. No subscript, so we only have 1 calcium. And then I go to the other side and I look at it, and I see that I have 3 calciums on this side. 3. Chlorine on this side, I have 2 chlorines on this side, so I'm going to put a 2 right there. And I go to the chlorine, I only have 1 chlorine on this side. Okay, now I'm going to go to my phosphate. I only have 1 phosphate right here. Okay, so we're going to put a 1 right there. Then I go over here, I have 2 phosphates on this side. So we're going to go ahead and put a 2 right there. So now I look at this and I said, none of them are matching. So what am I going to start off with? I like to save the polyatomic ion for the end. And the reason is because a lot of times the polyatomic ion will work itself out with everything else. And you don't have to worry about all those things. There are no single elements by themselves, so I don't save those to the end. So we're just going to go ahead and start right off real easily with the sodium. So I have a 3 here. I need to make the 3 on this side. So remember, I can only change the coefficients. I can't change the subscripts. So I only have 1 sodium here. So what times 1 equals 3, and that's a 3. So now I can change this to a 3. Well, but that also changes my chlorine. My chlorine now, I have 1 of them. Now I have times 3, so I have 3 of them. So now I've changed that, and now my chlorine is off, so I'm going to chase my chlorine. So here's how I'm going to do that. I have a 2 on this side, and I have a 3 on this side. So I can't make this one ever make my chlorine odd. So what I'm going to do is I'm going to make this number right here, okay, and this number right here, I'm going to multiply them together, and I'm going to get 6, and I'm going to make sure they have 6 over here. So I'm going to put a 3 right there, which tells me I have 6 chlorine on this side. So now I have to go back to this side over here, and we're going to change this to a 6. So I got to change this number right here to a 6, which tells me I have 6 on this side. But it has also affected my sodium. So I'm going to go past this, and I'm going to, in order to tell me I have 6 on this side. But now it affected this side, so I got to make this side 6. So what number do I put in the front right here in order to make this 6 sodium? So what times 3 equals 6, and that is 2. So I'm going to change this over here to a 6 now, because I have that. But it also changed my phosphate. How many phosphates do I have? Since I have Na3PO4 2 times, we're going to make sure that we have 2 phosphates. So I'm just going to come over here and put in my phosphate as a 2. Okay. Now, one thing I didn't change when we did this up here is when I changed my, put a 3 here, I changed my chlorine, but I didn't change my calcium. So I forgot to do that. So I'll go, let's look at the calcium. These are not balanced, but I look at this. I have 3 calciums. So if I put that in there, I have 3. Now my calciums match up. So I have 6 sodiums on each side, 3 calciums on each side, 6 chlorines on each side, and 2 phosphates on each side. So I have my molar ratio is going to be 2 to 3 to 1 to 6. And if I need to put a 1 right here, I can just go ahead and put a 1 right there. Don't have to put a 1 right there, but I can. So I'm going to go ahead and highlight that, and I'm going to look at it and say, can I reduce that? Well, since I have a 1, we know we can't reduce it, so we're going to go ahead and make that bold, highlight it in the color. I like green, and there's our answer. So our molar mass is 2 to 3 to 1 to 6, and we have a balanced chemical equation. So there we go for problem number 3 of worksheet number 3. Good luck with the rest of them. And as always, go Mohawks. Nelson out.